Hey everybody, it's me, John Park, and this is my workshop. Welcome to John Park's Workshop Live. We're live! So special time and day today, Wednesday. Usually my show's on Thursdays, but with Thanksgiving tomorrow, we figured it'd be best to do it today, because I don't think anyone's going to be watching tomorrow. Who knows? So quick roll call. Are we live over on Discord chat? That's the place to be if you're interested in the community and chatting and talking with people. I'm also going to pop up a quick YouTube video so we can check the chat there. Give me 1 second. Someone made a comment yesterday, live streamer, that no matter how many times you do this, you're always stuck looking for cables. I added another device. Dangerous, I know, but I added another device and therefore needed to find a long enough HDMI cable. So I'll show you the device. I'm excited about the device. And then no more. Then I'm going to calm down. But I think you'll like this. Okay, let's see. I've got the YouTube video up. And in a second here, we should get this chat to pop up. Live chat. Hey! There people are. All right. The video's not showing up, but that's okay, because that video usually freaks me out because it's on a delay. Let's see. Oh, I'm logged in as YouTube. I'm going to switch my login on YouTube real quick to me in case we have someone logged in as Adafruit already. A little behind the scenes action there. Hey, Northern Pike. Hey, C. Grover. Should I call you C. Grover or CG Rover? I never know which one. Even if you tell me which one, I'll probably keep making that mistake. Could everyone please include a pronunciation guide with their aliases on Discord chat? That would be awesome. Or maybe a voice sample. That would be cool. All right, YouTube. Here comes the inception delay as the chat pops up. I don't know if it's my connection. My connection seems to be solid, but the internet itself. C. Grover. Okay, C. Grover, thank you. It's not like net neutrality has already gone into effect, so I don't know why this would be acting slow. All right, there we are. Quick check-in and a quick check-in. Make sure everything's working. I'm also going to have to either step over here to do the chat or run inside and get my iPad that I usually use because I forgot to set that up. So let's get to it. Here I've got, first of all, I want to show you the new addition to my setup, which is that. Not a power boost, but the fact that you can see the thing. So these are the kind of three cameras I've got now. So I got my main workshop camera. I've got the overhead workbench camera that I put in last week. And now I've got this little down shooter that you can see here. This is the same one that Lady Ada uses for her live shows. I think she actually has one in her apartment for the desk of Lady Ada, as well as one at Adafruit for the Ask an Engineer show. So this is great. It's called a hover cam. Actually hard to find. They're out of stock most places, but I got my hands on one. And it has an HDMI out, which is the kind of key thing for the way my setup works. It has a decent autofocus. Not perfect, but I set it on, I think it's a locked focus right now, down here where things tend to be. So there's my camera remote. Here's an object. So excited about that. Let's see. I can move my little camera switcher back here, and I'll go to a main workbench cam and talk about what we're going to talk about. Okay, so last week we built the little demo of the Neo segment display. So that's this guy here. Actually, I'm going to switch back to that view for you for a second. I should go to this one. So I've got this Neo segment display, and I've also got my little phone pad keypad, Matrix keypad. And I had been playing around last week kind of on the fly with my interconnects for this thing. And so I wanted to, I had kind of a low clearance in the case that I wanted to make. I didn't want this thing to be too bulky, and so instead of a straight run of header pins coming down into the Metro that I'm using, which also has a its stack of header pins, I wanted to bend things to a 90 degrees. So this represented a couple of attempts at this. At first, I was going to use some of the 90-degree male headers that are used for soldering onto a board. The problem with these is that one leg of them is pretty short. Actually, I'm going to switch back to full big cam. There we go. So if you look at these header pins, they have a short and a long side. And the short side is just a little too short to reliably plug a jumper cable into it. So what I decided to do is actually make my own connectors. On the show last week, I tried bending some of these stacky headers here. Those are kind of thin, and I was getting an unreliable connection, and it's a bit janky, to say the least. So what I came up with instead is I took some of these raw female headers. So these have a little female crimp header, and these are meant to be plugged into, see if I have any around here. I don't have any, they're off to the side. Meant to be plugged into something that looks like, hey, I'm losing everything. Where'd you go? Something that looks like, if I remove the Kapton tape here, you'll see, well, that. Right, these kind of plastic headers. And they come in different widths, so you can plug in a 2, a 4, an 8, and so on. So these female raw crimp pins, however, on their own, without that plastic casing, do get a nice solid connection onto the short side of these female headers. So what I did was slipped a little heat shrink tubing over a bunch of wires, plugged them in to these headers, and then added a little dab of solder just to maintain that connection, because right now it's just, it's a little pressure fit, which could get loose over time. So I soldered them on, then slid the heat shrink tubing over. So if I put the Metro into view here, you can see the result. So that, let me see if I can autofocus that real quick for you. It may have just maintained that other focus. I think you can see that pretty well. So there you have a, let me see if there's one I can unplug. So here's one that I was just using. I ran out of black heat shrink, so I heat shrinked it and then wrapped it in black electrical tape just to know that that was a ground one. So I did some color coding with that, which is nice. And this one, I only needed to have this single wire going into ground. I didn't make a full row across, which would have been maybe a good idea in hindsight. But for this one, I kept one of the pins that's not being used on here just to give me a better mechanical connection. Instead of a single one which would twist side to side, this will stay put. So these are now sort of a similar situation on the other end. I just, on the phone matrix, I plugged a set of those female raw crimps right straight onto here. Those are not soldered on, so I might put some tape or hot glue or something to maintain. But actually they're snug. This is maybe a slightly thicker pin on here. These feel good and snug. So that's how I'm connecting my keypad back to the Metro. And same with the NeoMatrix. So the NeoMatrix, this already had female, or sort of rather male pins coming off of it, so same sort of trick. I slipped these onto here and they go to the board. So what this gave me is a pretty low profile connection. Another option with this thing would be to use there's a Metro that has that comes with no headers on it. I believe that one has through holes that you could solder to, so you could solder wires directly to it, which would be pretty cool. And on and on, there's a lot of options. But so that is how I sort of solved the problem from last week. Now let's talk about the larger scope of the project. So I'm going to take this off of that little clamp there. And so we had last week the NeoSegment and the phone keypad. And in the interim, I also added a speaker. I don't think I had that on last time. Zoom this camera down in a little bit. And let me know in the chat with lots of exclamation points, because I can just kind of barely see it, if you have any concerns about camera. I think that one's in focus, but I can't see it too well. In fact, hold on one second. I'm going to turn on. I have a couple of monitors over here that'll give me a bigger view. If you've ever wondered why a TV station employs a lot of people, it's because there's a ton of things to actually keep track of. Uh-oh. Did that break the... Whoa, what is that? What on earth? All right, I'm turning that up. Oh, you know what? This, that's a photo from our Alaska trip. I'm glad nothing embarrassing showed up. When I just turned on a monitor that this camera up here is plugged into, it used HDMI control to talk to the camera and convince it to start playback. It's doing it again now. That's funny. Sorry about that. Okay, so I'll rely on that monitor for this one. Okay, so I've got a piezo buzzer that I've attached to this so that I can have some sound feedback now. And then I also have added a button. So this is a little lighted switch, actually, on-off switch, and a couple of potentiometers. Now, I can demonstrate this before we put it together. I think that's probably a good idea. So what I've decided to do is take this concept of, originally I just wanted to test out the NeoSegment display and the phone pad and type numbers onto there. I have now turned this a little more into kind of a platform for building either a user interface or something like a music sequencer. You could use this to build puzzles. So for a crypto challenge, mystery box, escape room kind of thing. With the input of potentiometers, I've got two of them, button or switch, and the keypad, you've got a lot of options for things that could be keyed in. And then I've got the output of the digits, the color of the digits, as well as sound. So there's a lot packed in there. In fact, I was talking to a friend of mine, my friend Todd Kurt, and he said he had at one point built a little device that he used to program colors onto RGB LEDs. So he has a thing he makes called a Blinkum. And instead of going through the usual, it's a USB LED, instead of going through the usual methods of plugging it into a computer, he just wanted something that was a very quick programmer that he could kind of test these as they came in from the factory, make sure that things were working well. So we talked about maybe turning something like this into a NeoPixel programmer, which would be really cool. Add a port on there that's some sort of a standard that you're going to use, just 3 connections for the power, ground, and data line on a NeoPixel. Plug it in, and then use this user interface to tune the colors so that you can then hit a button that says go, and it sends that, or it could be patterns. You could have animation patterns built onto it. So the idea is kind of a little bit of a platform for hardware and software. So let me plug it in and show you what I've got it doing right now, just a little bit, and then we'll talk about building an enclosure for it, and then give it a full workout. So, okay, so first thing you notice, I have like a startup sound, which I think is usually a helpful thing when you're building devices that people are going to be using, is you want to see a light on when the thing starts, a sound, both. And so let's take a look. I've got this button not doing too much right now, but it's set up to output a serial print statement so that we know that it's working, and I have it set to light up, and it's also lighting up. This is on pin 13 actually, so you'll see the let me put this under the, let me put this under the new cool camera. That'll be nice. Let's see, I don't have a long enough HDMI to move that too much, so let me slide the operation over this way. So you'll see on here, it's not showing up as very red because of the lights, but you'll see there's a green LED, and then 2 spots below that, there's an LED that I'm seeing as red, and you'll see it go on and off there. That's the pin 13 LED. That's the same one as is on here. So you can see that lighting up a little better. And now check this out. When I go to the NeoPixel display, if we go into, this was me pressing the little star key. So what I'm seeing right now is I'm printing the word hue, and then I'm seeing a hue value over on the right as well as the color of that hue. So this is kind of like a little color tester. And I talked with, again, my friend Todd Kurt and then Tony DeCola about, hey, I'd really love to use hue, saturation, and value instead of red, green, and blue to talk to these NeoPixels that are inside the Neo segment. So, and the reason for this, HSV is another way to express color instead of a mix of red, green, and blue. It is a continuum of colors that goes 360 degrees around a wheel. So that's the hue part of it. And then saturation is sort of a linear value from unsaturated to fully saturated, and value, or brightness as it's sometimes called, is from gray to black in the luminance or the brightness. So just by converting this project over to use hue to express the red, green, and blue values, life gets a lot easier when you want to mix colors. So what I've set up now is, I think it's this top one, it'll be easier when it's in the case. I have a knob here, and I can dial in different values. So right now, again, I apologize because, let's see, can I set the brightness? I'm going to try to darken this display. It's a little hard to see on video. Let's turn the exposure way down. That's better. Ooh, that's a lot better. Hey, you can see them. Again, a little bit of frequency lines there. So as I change the hue, so we'll start at towards the bottom of the wheel, it's red, and then I get into yellows and greens. We'll get up to blue. And you can see for fun I'm also increasing the pitch of the speaker every time I press it. And then back up to red. And then what I've also decided to do is take that and use that hue value for other things, which I'll show you once we get it all put together. The other knob, since we've got this nice close-up right now that you can see, the other knob gives us a value, which is the brightness. So we can dim it basically with, and that's full brightness, which you can see the white kind of starting to peek through there. But that is kind of blindingly bright for me, and here not so bad on the camera. I'll turn that down to something a little more moderate. Okay, we'll fix that exposure back to something about there. I know you can't see the LEDs too well now, but we'll look at some other stuff as we put this together. So that's the idea behind the project, and what I want to do now is, if we take a look at this mess of stuff, what we got to do next is come up with an enclosure for it. So what I'm going to do is switch over to the computer and show you a little bit of the workflow that I used to come up with an enclosure for this, and some of the little tips and tricks for developing a laser cuttable enclosure, which is similar to some degree to setting things up for, let's say, a plasma cutter or a water jet. because you can deal with incredibly thin lines, almost no tooling to worry about. Or you may adjust this a bit for more of a CNC workflow, but you'll see a hallmark of this type of construction is, let's see, has my camera, oh, that camera didn't switch, that's weird. I don't know that that changed over to broadcast what I wanted you to see. Let's push that over. All right, one second. I'm going to go over to the computer and see if you're all yelling at me that everything broke. I hope not. Yeah, someone asked about on YouTube asked about you could have letters on Neo segments, but this doesn't have so many segments. So yeah, the Neo segments can do. I wrote it down. I actually have it in my code that I can show you the letters that display well. There are plenty that don't, like M and W and X, anything with diagonals. So is that thing just pegged? The CPU is pegged on this machine, so it may be lagging a little bit on. Hey, Matambale, you say awesome t-shirt. Thank you. I actually was thinking of doing a joystick-based project today, but bailed on that when I hit some difficulty. So I'll be doing a joystick project coming up. This is a t-shirt by my friend Coop, Chris Cooper, and he's an awesome lowbrow hot rod artist dude, amazing artist, and this is his version of a Atari joystick. So I'm not sure why, but my broadcast display is lagging behind what I'm telling it to show. So quick roll call over in yeah, those are. You see me and your chat right now? Tell me when you can. Oh, now it's switched. Okay. So over in chat, just let me know if you're seeing me, and in a second here I'm going to have Rhino up. So let me pull up Rhino. Where'd you go, Rhino? And I'm going to switch over to this view over here. Yeah, there's a chance that my machine is feeling a little inundated with USB inputs coming from the HDMI, so it's frozen, huh? All right, I think I'm gonna turn off the close-up cam and see if that improves our lives at all. Seems fine. Audio has some clipping. Yeah, I think it's when I'm switching between camera views that it's having problems. Okay, well, you can see Rhino. I won't mess with anything else because that's what I want to focus on for a second here. Lag is gone. Okay, great. So you should be seeing a CAD drawing. So nod if you can see a CAD drawing, and then I'm gonna go into sort of the workflow of how I got here, how we ended up with this. And it looks like it's, yeah, it looks like the camera switching is laggy, but this has got a pretty good refresh. So another thing that I did was I am using a different type of setup for showing the screen capture, and so now my cursor is actually where I put it. So in the past, when I went and highlighted text, you saw that my cursor was about 3 lines up above. So right now you should be seeing me touching this circle and picking this circle. So, okay, good. So here's the workflow for how I got here. In the first thing I did is I went through and looked at drawings, technical drawings, or just took measurements with calipers of some of the key things. So this is the shape of the bezel for the keypad, and this is the placement and size of the holes. Intermittent audio buzz, maybe my USB hub needs power assistance. Yeah, it's interesting. I have a pretty high power hub, but I think I'm taxing it a lot. So hopefully that buzz isn't too bad. And if it is, I will look at adding a hub. Let me know, by the way, if anyone knows. I'm using an old iMac here, and if anyone knows of a way to add a external USB bus, like a PCI bus or something like that. I don't know if there's like lightning to USB, something that adds like a full-blown other bus of USB. That would be helpful because I have way too much on like 2 buses that are internal on this machine. Okay, so I started off with creating these curves that are the size of the keypad, and this one is the size of the Neo segment. And then these holes here might be familiar to some people. That's the pattern of the Arduino Metro, the Arduino Uno and the Adafruit Metro. So this piece here, I'm gonna do a bit of this from scratch. So once I've measured out and sort of roughly placed these things, and let me bring up a bit of UI here. Okay, so let me move this stuff out of the way here. So this is what I'm starting with, saying, okay, I got to fit some stuff. Then I went and sort of dry fit that onto a piece of cardboard and saw that I couldn't go, real tight in close to things because then I wouldn't have room for some of the wiring mostly. And I have some buttons and things I want to add. But let's say this is, and I'm just eyeballing this, but let's say this is the size of the enclosure roughly that I want to make. Then what I did was created some sides for it, and the depth of these was based on the 1.5-inch screws that I had on hand. So I had some number 6 screws. Usually I use metric, but I had some number 6 screws by 32 turn, and they were 1.5 inches long. So I came up with a proper size. I'm just eyeballing this here right now. So what you do when you want to do finger joints, and I can grab a piece of this so you can see what I'm talking about here. So this is a common way of fitting, of joining things in laser cutting, and it's similar to joinery in sort of real furniture. But you can see here by creating tabs that are at the same depth as the thickness of the material you're using, you can cut in this 2 dimensions and then reassemble in 3 dimensions. And I've been building stuff like this for a number of years, like 10 years or so, so it's become fairly intuitive without even necessarily building it in 3D to know how to assemble something like this. But another method is to build your object in 3D and then sort of reverse engineer the curves from that object that you'd need. So knowing that my material is 1/8 of an inch thick, what I'll do is I'll make a little 1/8 of an inch square. So I'm going to type in 0.125 inch and 0.125 inch. Okay, so this little 1/8 inch square, I know if I cut that depth out of, let me move this properly. Okay, so that's right on that line. So if I cut something of that depth out of, let's say, this piece and jut that out from this other piece, I will have a nice seamless joint. And they don't have to be square. This is the depth that matters, but this sort of height here, so this in this view, this width matters, but this height doesn't. I can create some nice little tabs that will interlock and keep the thing closed up. One thing I see people do sometimes is they will just put sort of endless, like every other 1/8 inch, they've got a tab, which is a certain look, and it may end up being stronger. It kind of creates more connection points between the two. But I found that often you don't need to, you can space it out a bit, and you don't necessarily need that. So I'll take something like this, and I'll mirror it across the midpoint here, and then maybe I'll duplicate one and place its midpoint. Sorry, I got to turn off center snapping here. I'll place its midpoint on this line's midpoint. And you can see those little pop-up windows telling me when I've reached some sort of a condition for snapping. So that's not exactly how they made the one that you'll see up here, but let's pretend that's the way we want to go with this. Then what I can do is create essentially booleans. So I'm going to union these tabs to this piece, and I'm going to carve away or difference those tabs from this piece. So that looks something like this. I can pick these pieces and do, and by the way, sorry the highlight color isn't very easy to see this yellow. So I'm typing, you can see that, right? Yeah, I'm typing curve boolean, and then it says, what do you want to keep? And I'm just going to click on the parts that I want to keep, and you can see it's making a single nice, move this off to the side, single nice, whoops, move a little further off to the side. So that's my new piece. I told it not to delete the old stuff. I can actually get rid of that, but I still need these tabs here to carve away. So you can imagine what's going to happen here. I'm going to do another curve boolean, and I'll just keep this part, and now I can delete all of that jazz there. Oops. And so now I'll have pieces that will join together nicely. If you want to visualize this stuff in 3D as you're building it, which I recommend, because sometimes what you'll find is you'll forget to account for things. Here, I'm gonna dummy up an example here. If I build a let's see, I'm just going to duplicate this one to do that actually. So if I'm going to build this back piece here, I will rotate that down. Okay, so if I take this and this is crude, but I can actually scale it and it'll all work. It'll just have wide tabs on it, but that's fine for this case. So I'm going to just take that from there to there. And how about, I won't worry about cutting these tabs out in interest of time, because we got a half hour left. So this looks sort of reasonable, but watch what happens when we take this into 3D. So I'm going to take these three pieces here, and let me go to a perspective view. And I'm going to make planar surfaces of them. And then I'll extrude those planar surfaces 1/8 of an inch. And so I'm just going to type in 0.125 inches. And then I'll cap the tops of those just by duplicating what was there. Boop, boop. Okay. And I'll just join these into single objects. I didn't carve these windows out of there. I would recommend that. I just didn't do it in this case. I forgot. So now let's take a look at how this would join together. So I'm going to take this and move it over here. Let's see. I didn't get that pivot great, but I'm going to rotate it anyway and then put it into place. So if we take, let's say that there. Okay, that joins up nicely. And now we'll take this one, rotate it there. We'll pretend those tabs exist, and in the cutout of here. And if I move that into here, you'll see. Okay, that would be fine, but these are intersecting each other. We shouldn't see these intersections. This actually, I made it too wide. So the width of this original, let me go to top view again. The width of this original piece forgot to take into account the 1/8 inch of depth of this piece of material that's going to land here. So these you'd actually need to properly construct, or I can show you if I just chop these off. And I'll just curve boolean that. Okay, that's what that should look like. Make sense? So this is this piece accounted for. So if you look up here at my the one I made, actually, sorry, I flip-flopped those. So I made the sides the full. Oh no, that's right. Yeah. So I made these sides the full sort of depth of the box, and then this top piece here is accounting for that extra depth of the material here. So let's see, other things that I did. Okay, so I made some little cutouts for vents. I stole a couple of these pieces from my Crypto Countdown Challenge box. So if you remember this guy here, I built a laser cut panel for this. And if you don't know this one, go check out the Mystery Box Crypto Countdown Challenge. So this button here I'm reusing, so I was able to reuse the CAD drawing I made for that, and same with the positioning of and size of this piezo buzzer and its screws and the USB port. So all of those things were reuses, which is nice. I just copy and pasted them. So there's my piezo and there's my little USB port. This piece here that I'm cutting out, I'll show you when we go to assemble this now in a second. This is a cutout to fit the Neo segments. These are two pieces that I just needed some scrap wood to, since I decided to build this from wood instead of acrylic. And you can do this with acrylic as well. You can use acrylic cement. But with wood, I knew it would be very easy to, there's not a great way right now to mount that Neo segment without there's screw holes on the back, so you could mount that to a thin plate of something. But for the type of construction method I'm using here, I wanted some ears or something that would offset from the object and allow me to clamp it sort of into the back of the case. So I'll show you what I mean by that. But these are just scrap wood pieces that I laser cut that I hope I remembered to keep. I think I did. So if you look here, that's that piece cut out, and I got to go fish in my scraps for the two pieces that I forgot to keep. Yeah. Oh, here they are. So I needed these two guys here. Someone said in the chat that, yeah, if you go to makercase.com, it's a parametric case generator, which is fantastic. And especially if you're just trying to make a box, give it dimensions, it does the finger joints for you, and then you could take that. I think it outputs probably an SVG file or an Illustrator file that you can then go and modify further. But that's a great starting point. I definitely recommend that if you haven't built these types of things before. These are knob holes for the potentiometers, and that's about it. So let's cut to, hopefully this will not slow the machine down too much as it tries to Sorry about that. So I'm hoping that the camera has switched properly because I was having some problems in Wirecast where it looks like it, yeah, it doesn't want to get away from it. I think I've crashed Wirecast. I don't know. Can you hear me? I think Wirecast has been eaten by the movie. I'm gonna try to quit. Hey, all right. It looks like I'm broadcasting again. I will not touch that movie, I promise. Thing ate the machine. Too much data. So let me know if you see this back again, and I'm going to actually see, can I convince the, yeah, I don't think I can convince the Facebook stream to restart. I'm going to get the new, I think this is probably a new stream key, so let's see. Yay, we're back on YouTube. You can see me, you can hear me. Thank you. Okay, I'm just restarting the YouTube stream. Sorry, not YouTube, the Facebook stream. The Facebook stream does not, it ends, and I have to hit some settings back into it. What is the title of this one? Well, we'll pretend it's this. Oh, good, I misspelled matrix down at the bottom of my caption. That's awesome. I'm going to go fix that. Yeah, remember last week when I corrupted, I couldn't restart Wirecast because I had corrupted the sort of session file. I did that again this week right before, about 10 minutes before we started. I had the whole setup, and when I corrupted it, I rebuilt it very quickly, and during the very quick rebuild, I misspelled the word matrix. So let's fix that because that's going to bug the heck out of me. Woo! All right. Fixed. Okay. Hey, thanks everyone for hanging in with me. It's John Park again. This is the, especially because the Facebook stream is restarting, I'm re-introing it. So I have just built a laser cut case out of wood for the NeoMatrix Mark I. And this is the file that I built to cut curves in Rhino out of wood. And then the other operation I did was etching. So let's turn over to this raster layer, as I'm calling it. And I'll leave on the vector layer. So these are essentially raster graphics that get etched a line at a time instead of vectors that are followed by a more mathematical curve. So these dark black parts, these I then run a second, actually this is the first pass I did. If you saw that video that looped 5,000 times earlier, what I do is I set the material in, and then I have the laser on a low power, high speed go through and etch in, essentially burning the surface without cutting all the way through these patterns. So I put a little border around where the keypad is and the display, and then I put some markings for the potentiometer so that, especially if you're going to use this in a puzzle setting or as something for, let's say, a music sequencer, because this NeoMatrix Mark I is an interface that you can use to make anything. It's the interface of infinite possibilities. So you may want to have some markings for your potentiometer that are not just you're experiencing something changing, but you can say, oh, if I go up to that mark, I'm going to be at yellow on a color hue wheel, or that's going to be a particular pitch for a sound thing. And then I've added some other markings here that are to be used in puzzles. So these files are going up in a tutorial that I'm going to be posting on Adafruit Learn Guide that you'll be able to build your own, or if you don't have a laser cutter, you may be able to get access to one at a makerspace, or you can also send files to services online that will laser cut for you, Pinocchio being the one that I can think of right now, but there are probably others. If anyone's had experience sending off files for laser cutting, go ahead and put some info in the chat. We'd love to hear about it. So I'm going to switch over now to the workbench, and we'll take a look at these files that have been cut and putting them together. And I'm cutting it close, which has got a little bit of time. So here you can see, I'll switch to this camera view. Excuse me. Close up on those. So here you can see this is the etched patterns in the wood. I etched them fairly lightly. You can use higher settings to get a darker burn on that if you like. You could also paint this, then etch if you have a safe paint, or you can use dyes. So that's the faceplate. Here is my button knob side. This is my button side. This is my USB port side. That's extra. These I'm going to use for attaching the screen in. So let's go ahead and start attaching stuff. So the way that I have this laid out, I'm going to take everything, bring it over here. You can see I wired this already. And what I'm going to use, let's start with the microcontroller, the Metro here. And I'm going to zoom in a bit on this view. So for that, I'm going to use these little. Let's see if this camera view will be helpful. I'm going to use these little hex standoffs and medium and short nylon screws. So the medium one will come up from the bottom of the board in this orientation, then this hex standoff, and then we screw down into the board with this. This is a nice way to assemble this. So I'm going to start with that there, and you know what? I think I can do this under the little down shooter camera, and you'll get a better view. Uh-oh. Yeah, it switched. Oh, don't crash on me, thing. I'll move this operation over here. Okay, so here's this little hex standoff, and actually I can't twist that from that orientation because the I'll find my screwdriver. The header gets in the way. So I'm going to do that from that side. Oh, what have I done? I'm using this entirely wrong. Hey! Yeah, let's put these on first. That's what I meant to do. So medium screw comes up from the bottom. Hex standoff goes in like this. By the way, these little hex standoffs, sometimes I do use them as a nut, like I was just using there, because they're really easy to grab and turn with your finger instead of if you have a regular size nut, sometimes you can't grab it because these are tiny. There's a M2.5. Okay, so you can see what I'm doing there. I'm building a little nice home for the Metro to sit up on top of. And again, apologies for the technical difficulties. I think we'll end up a little bit long today so that we can finish this build, and then we can focus on Thanksgiving if you celebrate Thanksgiving. Okay, so now the Metro gets placed on top of these, and then we screw in from the top with these little baby screws. Oop. It's a little tricky. There we go. It feels good to have these secured nicely onto there, so that's not going anywhere. There we go. It sure beats just foam taping your microcontroller to a case. Not that that isn't a valid way to do it sometimes, but it's nice to have a good mechanical connection like this. Okay, so let's go back over to this camera here. So now I've got my matrix display, and you can see here's a case of why I placed this amount of space here. Is again without, now I could have gone with the little 90-degree connectors maybe, but without doing, I just need a bit of space here for this connection. Let me zoom out a little, this is a bit close. The two little pieces, remember I showed you, these are going to go, so I've already, speaking of foam tape, I foam taped the Neo segments to that cutout window. So this would be the one we'd be using, but I already had one on here. These fit pretty snug into here, but just for a little extra, there we go. Just for a little extra security, I'm going to foam tape that there, and glue their bottoms to the wood. So that's really not going anywhere. So I've essentially made like a little box that the display lives in. Now, I did shrink the little window here a tiny bit from my last one because the last one felt a little loose. So I'm having trouble. Let's see if I get it in there. I don't want to break that display, but I want it in there solidly. That's good. Okay, good. That's not popping out. That's in there nice. Yeah. Okay, so these, the nice thing with working with wood is versus acrylic on this is that you can a little more easily refit things with wood. With acrylic, it just cracks. There's not a lot of give. So let's take some strips of tape. Let's go to this view. This is my friend, the good stuff, the good 3M foam tape. And I'm just going to trim that into little thinner strips. And I'll put this like so, and so. And then I'm going to glue the bottoms of those and then press them onto here, so that's like a double whammy of adhesion. So I'm going to get a little wood glue. And someone asked this question earlier in the chat about building these types of cases. You can put this together without glue because I have some screws and nuts that are acting as compression. But it's a good idea to glue them. You get a better connection. So I may throw down a little glue around the edge for 5 of the 6 connections we're making, and then I'll leave the bottom so that it can unscrew and we can lift it off and get inside. So I don't want to glue it entirely. Okay, so I'm going to hold that and try to let that dry a little bit. Let's do both of them at once, actually. Yeah, another thing I'd recommend with this, I kind of liked for this project, for whatever reason, having a wood, raw, laser cut look to it, and it's definitely a look, this nice crispy caramelized burned edges against the white Baltic birch plywood screams laser cut stuff. If that's not the look you want, It's not super easy to stain the Baltic birch, I've found, but you can try staining it. Even better is painting it. You can prime it and then spray paint it. That was a recommendation again from my friend Todd Kurt. He said that Carlin, his wife, Carlin Ma, who's an awesome maker, she always recommends priming it first. It looks better. Todd said, nah, just go in there with some red spray paint. You can also sand this stuff, distress it. Like the edges, once you put this together, they're very hard, right angles. You can go in and sort of soften that up a bit. There's a lot you can do. I think a lot of people stop at the laser cutter and say that this is done, which is what I'm going to do today. But all right, so there we go. We've got the display really nicely in there. I hope I put it in right, but it looks like I did. And let's start adding the keypad. So the keypad, I'm going to use these longer. Let me move over to this camera for you. So for the keypad, I'm using these longer screws, which will come in from this side. And I didn't show you this, but this is a nice. So by measuring that, and I also use the technical drawing, by measuring that, this sets in there and just hangs out, which is great. It's a very nice fit. And let's pop the nut onto there. See how I'm like barely able to get a hold of and turn that thing? And I won't use it in this case, but I do have like a little socket that'll drive that a little better than my finger. But sometimes using the mini standoffs just as like a 3 times height nut, and if you have the clearance for it, it's a nice option. I threatened to go get my iPad to look at the chat, but I think I ran out of time to go do that. I can't see the chat from here right now, so I hope you're not all screaming at me that you froze and nothing's working. Let's have a look real quick. Can you understand why I'm paranoid at this point about the stream crashing? I think you can. Stay on the bench. This camera shot isn't working. I missed that, so I don't know which one you liked. Video source switch. Oh, okay, it's not liking it when I switch. So I'm gonna do one last switch here and go to this view. And stay on that one. So at least you get a macro view of what's going on. And this one I made a little bit of a tight fit. I think I have a slight mismatch between the hole in the wood and the hole in the plastic, so that screw went in at a little bit of an angle, but not too bad. Yeah, I think maybe I've got too much data streaming in on this computer to handle a lot of camera switching. So I will minimize those switches for now. And then maybe prioritize getting another computer. You know why I'm dreading getting a computer? A, it's going to be expensive, but B, it's all of the files and setup and stuff. Like getting those things off of your... Oh no, I just lost a camera. Well, you can still see what I'm building, hopefully. As if on cue, right? Let's pop that back in there. Okay, so let me throw these. These potentiometers have threaded shafts on them, so I could put those in like this. And then I have some washers and nuts I can throw on there. And I'm going to go turn that camera off for a second and see if that was just a case of it overheating. It's not that hot here today, although it's going to be 93 degrees on Thanksgiving in Los Angeles. Is that crazy or what? Not cool. 93, I say. Unbelievable. And these ones, I don't want these moving, and I trimmed the little tabs off of them. So I'm going to use a little bit extra torque on them. So they, again, you can't do this sort of thing as well with acrylic, but with wood you can squish down into it pretty nicely. Okay, let me just turn that camera off for a minute, and then we'll see if we can bring it back up later. I'm going to hide that one so we're not looking at color bars. And I think that'll give us a little bit of a laggy switch for a second, but I'm just going to put these knobs on, and they just press fit on. Okay, that's everything for the front of it. I actually didn't, I've already got this, this button switch here connected. I forget where, I think I'm throwing that over on this side. And then, oh, one other thing I've got, USB. I want to be able to access the USB on this. In the configuration I've built, I was thinking it would be for a puzzle, something you go and plug in somewhere and use. So I didn't put a battery in it. You could do portable power with it for sure, but I'm actually going to run a USB extender, a little panel mount extender, over to, let's see, I think over here was where I had decided would work well. I'm going to run it over to here, and then I think I've got this button up top. Oh wow, that camera still has not switched away from the color bars. That's disturbing. Yeah, that's where the button will live. And this I'm going to loop around once to shorten. Everything is dancing around on me here. I think something like that. So let's go ahead and screw this in. So these are these little panel mount USBs, and I'm using it right in this case. I think it was some other project I was doing. I think my cigar box, or yeah, the cigar box, I mounted it all crazy on the outside. But these things for some reason have ginormous long screws. So I'm actually using a little impact screwdriver electric screwdriver to get those started and get them finished. Actually, let me thread that through a little bit. I wish I could see the chat from here. M2 screws, I think these are M2.5, if you were asking about the little black nylon screws I'm using everywhere. These are the M2.5. I think, check and see, because I've got packs of M2s, 2.5s, and 3s in my workshop of those types, and I think there's only one that we sell on the Adafruit store, and this was that one. I think this is the 2.5. I don't know why this, I guess they thought you might be going through some crazy thick material with this USB panel mount. Okay, so we're getting close. We've got USB, we've got button, and then top and bottom have nothing on them, and the back side has this piezo buzzer. So let's do the piezo. So this will be like this, and like that. So same thing as my previous connections. I'll use these. This is the longer length of these 2.5s. Where's that little box? I think I put it away. The long ones are what you need for most of these outside the panel to inside object connections. And then the medium and small are good when you're using the standoffs. Okay, I think I'm going to go ahead and power it on just to make sure that things seem to work before I fully close it. So I've got a USB. That's a good sign. We have sound. Good. Okay. I'll say that's probably working well enough to assemble, and then we'll fully test it. So here I would probably recommend gluing. I'm not going to do it right now in the interest of time, but I'll probably put this back together on camera for the tutorial yet one more time. Getting a lot of experience with it. Oh, before I do that, so here's how someone was asking about the connections. So here's these number 6 screws. I know I'm mixing metric and imperial or SAE. So what I'm doing is bolting them from the top through to give myself something to connect to. And these are little cap head hex screws, which are a little more finished looking on a project like this, I think, than a Phillips or a flathead. I really hope you're still not seeing that no signal color bar thing, but I suspect you may be, because in Wirecast I see 2 camera views. I see the shot that I've told it to display, and then I see the shot that it's actually broadcasting. And just like when it crashed before on that movie, I'm seeing that thing didn't want to change. You can see how it'd be nice to get those side panels glued in place so that things aren't flopping around. It actually takes a bit of dexterity to get all the 4 sides on and then pop the top on. I think I will actually start it this way, just because getting those holes fit is tricky-ish. And let's see. Oh. If I can then start fitting these in. Again, a reason that I've started to, over the years, use fewer finger joints is that it's a lot easier to pop 3 tabs in than 12 tabs running all the way up and down the thing. Okay. Good. That's actually holding. These, I put these slots in kind of for airflow. One thing you could also do if you're adapting this for other sensors, if you wanted to add distance sensors or a light sensor or a microphone or whatever your project calls for, you could run wires through those little slits if you had to, but better is to make an adjustment to the CAD file, which I'm going to include as a SVG. Come on, thing. What's not? Oh, that's the one that's not going. All right, I feel something bumping in. Is it you? No. Oh, I've missed the screw. Huh. Here's my little favorite, this little sort of pick has a nice hook on the end you can do to coax this screw back. There we go. Okay, and while I've got all those parts in, I'm going to screw on the nuts for the bottom two here, just to keep that under a little tension. Again, this using tension thing, slightly dangerous game to play with acrylic, works really good with wood. And I have a socket driver for that. Oops. By the way, that little power boost I was showing at the beginning, that and a LiPo would be a really good option for battery power. This won't quite fit a regular battery case for alkalines, the AA's, the 4 AA's. You could make this bigger. I just didn't have big enough screws, honestly, to build it the way I wanted to build it and put that kind of a battery case in. And with a little finagling, it goes in place. We'll put our last screws in, and then we can test it out. I'm going to, with great trepidation, check the chat to make sure that you're still getting a video of any of this. Please tell me you are. What, no lock washer? Yeah, that'd be good. Okay, good. It looks like you're seeing that. I'm going to give it a little workout in this position before I dare changing the cameras. So here's, and this is a good view of this, so here's power. I'm going to darken, if I dare, the exposure down a bit. So there. Okay. So we've got 3 things we can do. We can enter numbers. And a little change I did in the code from last week is now I clear when I hit rolling back over. Remember last week I talked about the software a bit. So the modulo 6 brings us back around to this position. And it sounds really nice and random. Let me lift this off there so you can hear the speaker better. Then I can head over to this hue adjuster and bring that value down. I like that one. So now, and you can see I've also pitched it up when I'm at a higher hue. So this could be a really maddening puzzle that involves getting a pitch correct, getting a color correct, getting a set of numbers correct. And then I am just simulating this right now, but let's say that we've done everything right with the pitch or the color or the number or the combination somehow of those. When I press this pound key now, that's the enter, as if we're trying to see if we've got the puzzle correct. And then if we do, it will return the next clue that we need for some other part of an escape room or a puzzle. Acorn? What's acorn? And you can see there it went through some colors that you maybe have to write down real quick and then use those colors with those letters as the part of your next clue. So let's see, did I break it? Oh, that's stuck down. So there we go. That is the NeoMatrix Mark I. I'm going to dare to switch my camera and turn on my main cam and see if it can. It looks like it did it, and then we'll see if that catches up over there. Thank you. It makes awesome sense. Can you buy this for a 5-year-old? Well, you know what? I'm not selling it, but I am building. I'm putting together a learn guide that will give you all the software you need and show you where to get the parts. Let me get out of that view. Oh, my cameras are cockamamie. So this display is pretty unique, and that's why I'm using it. So it's based on NeoPixels, which means any NeoPixel code can run on them, but there's also a library, NeoSegment library, that makes it easier to use this as a display. And it's hard to find. I don't know if there are any really easy to use examples of RGB character matrices or character displays like this. You can, however, use regular 7-segment displays. We have a bunch of different ones in different sizes and different colors that display a single color in the Adafruit store. So you could definitely modify this and use one of those sort of more easy to find. The NeoSegment is a specific product that you'll have to go to neosegment.com to get yours, or through Crowd Supply, I think. But if you want to go simpler and use stuff just in the Adafruit store, replace that with a regular character display, and then the software examples that come with our displays will work. You can modify the code to have the keypads talk to that instead of talking to the multicolor display. And then you may want to add other NeoPixels to it so that you can use some of these color changing knobs and value knobs to do something interesting. So that is my NeoMatrix Mark I. I hope you enjoyed it. Thanks for coming to the stream. Thank you for putting up with the funny camera action and the stream restart. I appreciate it very much. And also, I want to say happy Thanksgiving to people. And I want to say that I have great gratitude and want to give thanks to everyone who's part of this Adafruit community and part of hanging out in these live streams and in the chat and giving feedback and participating. It is really a thrill to be involved with this community, and I hope you have a great Thanksgiving. Thank you so much. I'm John Park for John Park's Workshop for Adafruit, and I will see you next week back on the regular time and day, Thursday at 4 p.m. Eastern. Thanks so much. Goodbye.